Okay, this is arc length day 6 notes. I'm going to do the warm up very quickly together. When you want to find the value of theta, remember theta is like an x. When cos of 4 theta minus 8 equals sine theta plus 3. These two values right here have to be complementary, which means they make 90. So we take 4 theta minus 8 plus theta plus 3 and equal them to 90. Theta's like an x, so we have 5 thetas, and we combine and get negative 5 equals 90 plus 5 plus 5. 5 theta equals 95. Divide by 5, and theta equals 19. All right, we're going to talk about arc length today, and that is the distance of a curved measure. And for example, if you wanted to walk a curved distance from here to here, I know we talked about before how many degrees this would be, but now we're actually talking about the length this would be to travel. So circumference is the distance around a circle. A sector is a portion of the circle enclosed by 2 radii of an arc. Arc length is a portion of the circumference. So, if you remember, the circumference formula, which is on our formula sheet, is pi d. But if I don't want to go the entire circumference around, I only want to go a portion of it, we're going to put a fraction in front of circumference. It's going to be a fraction out of 360. And that amount on top is going to be the number of degrees out of 360. And you're going to get the degrees from right here. So let's look at number 1, which says circle O has a radius of 10. We want to find the circumference or arc length of the following. First, the whole circle. That means we're going to do the entire circumference, pi d. Now, if the radius is 10, our diameter will be 20. So pi times 20 is going to be 20 pi. Half the circle. Halfway around the circle is 180 degrees out of 360 times our circumference, pi times 20. And that's going to be, if you type it in your calculator without the pi, 180 over 360 times 20, we get 10 pi. A quarter of the circle is only 90 degrees out of 360 times pi d, which is 20 again. And this time we get 5 pi. And if the sector only has 60 degrees, so this means it's only probably about that much right there, it's going to be 60 out of 360 times our circumference again, pi times 20. And this one, if you put it in your calculator, 60 over 360 times 20, we get a decimal. We'll math fracket, 10 thirds pi. All right, we're going to look at some more questions a little more closely now, where we have some diagrams and some information in them. So we have a ball rolling in a circular path. So think about the ball is here, and it's going to roll from here to here. So it didn't go all the way around the circle, just a small arced path. The radius is 10 inches, and the arc measure is 54 degrees, which remember also means this angle is 54 degrees. Find the exact distance the ball has rolled. Arc length is degree over 360 times the circumference pi d. So arc length is 54 degrees over 360 times pi, and our diameter is going to be, the radius is 10, it's going to be 20. So they want the exact distance, so that means we're not going to type pi in our calculator. So let's type 54 over 360 times 20 in our calculator. And we're going to get 3 pi. And this is inches. Put arc length there. Find the distance it has rolled to the nearest tenth. So all they want us to do this now is find what this is in decimal form. So we can take our calculator, type in 3 pi and hit enter. And if we round it, my calculator right now says 9.424777961, and to the nearest tenth, that would be 9.4 inches. All right, number 3, find the length of the arc to the nearest thousandth with a circle 75-degree central angle and a radius of 6. If you'd like to draw, here's a picture. The central angle is 75 and the radius is 6. Arc length is degree over 360 times the circumference pi d. So our degree is 75 over 360 times pi, and if our radius is 6, our diameter is 12. Now they did say to the nearest thousandth, which means we want a decimal, so let's type everything in our calculator. 75 over 360 times pi times 12, and we can go right ahead and round off of our screen, and I have 7.854, and this is going to be feet. All right, let's hop to the back. All right, now a little different on number 4 is that this time they want us to find the angle. The angle is missing. 9 feet is the length. 15's our radius, but the angle is missing. So we're going to use our arc length formula. Degree over 360 times pi d. We know the length, it's 9 feet. We don't know the angle, it's x over 360 pi. And if our radius is 15, our diameter will be 30. All right, how do we go about this? Well, we've got to get rid of some stuff. I'm going to get rid of that 360 first. And if we're dividing by 360, to get rid of it, we're going to times by 360 on both sides. So they're going to cancel here. So 9 times 360 is 3,240. Now over here I still have x, pi, and 30. What do you think we can get rid of next without making too much of a mess? I'm going to divide by 30. So these cancel. So now I have 108 equals x pi. And I guess I got to get rid of pi now. And I get, we're going to round to the nearest degree. So if I type 108 divided by pi in my calculator, I end up with 34 when I round degrees. All right. We're going to do a little jump skip down to, how about number 6. A sprinkler system set up to water the sector shown in the diagram. The angle's 57 degrees. Let's put it in our picture. And the radius is 20 feet. Now remember, there is more of the circle here that they're just not showing us. The arc length AC is what they want us to find. So that's a pretty realistic question. If you have a sprinkler, you want to kind of know how much of a distance your sprinkler is going to be covering. So our arc length formula, again, this is good to write down every time, degree over 360 times our circumference, pi d. So arc length, our degree is 57 over 360 times pi, and our radius is 20, so our diameter is 40. Again, they want us to round to the nearest foot, so if they want us to round, we can type everything in our calculator. So we're going to type in 57 divided by 360 times pi times 40, enter, and let's round, and I get 20 feet. All right, and I think that's going to be good enough for today. The rest of the questions are a little more practice if you'd like to try them out. Otherwise, you can go ahead and work on your homework.